Here's another example where we'll do it twice. Once where we see the derivative reduce away, and then the other one where we algebra our differentials into shape so we can make a more direct substitution. In other words, what I'm going to call this spotting the derivative method, which usually aligns more with your textbook. So this is the way I like to do it, and we're going to say, okay, so what are we looking for? We're looking for a function and its derivative. So I see that I have a function, z squared minus 5, and then its derivative. Now you may be thinking z squared has derivative 2z, right? And we have just z, but keep in mind that constants, we can work with them, they're fine. So it's not the exact derivative of it, but it's the derivative-ish. And all we're looking for is the derivative-ish. It will be fine. So what we're going to do is we're first going to say, all right, equals, all right, carry our equal sign down here. Actually, I'm sorry, equals circle star. So now let's make our substitution. So u is going to be our function, the one that's hidden inside the other functions, and in this case, the square root, z squared minus 5. And that means du dx is equal to 2z. And then my way, I say, okay, well, I want to substitute directly in for dz. So, or I'm sorry, that should be du dz, not du dx. Du dz. So to solve for dz, we're going to take du equals 2z dz, and divide both sides by 2z to get du over 2z is equal to dz. And this is going to be the substitution that we're going to use. So now making that substitution, our integral becomes, well, we haven't done anything with the z out in front, so the square root of u, and now dz becomes this expression right here, du over 2z. And so now we just approach this and say, well, we've got a problem. We've got two variables in our integral, but notice the derivative, the z, the variable part of it, reduces away, and we're left just with, well, this 2 there becomes just 1/2. So I'm going to go ahead and pull that out in front of the integral. 1/2 square root of u is going to become u to the 1/2 du, and we can absolutely do this with a power rule. So we'll go ahead and do that real quick. We get 1/2 times, well, u to the 1/2 plus 1 means u to the 3/2. So 1 over 3/2 is 2/3, reciprocal of the new exponent, plus z. Now we can't leave our terms in our answer in terms of u, so we have to back substitute for our substitution. And while we're at it, we'll clean up the algebra a little bit. 1/2 times 2/3 reduces to 1/3. That u term is now reverse substituted back to what it originally was, z squared minus 5 raised to the 3/2 power plus c. And we've done it. There's our answer. So now let's do this again, only with what typically is more the book way of doing it. And I emphasize, they're both good. One's not better than the other. In fact, it's important to be able to spot the derivative more the textbook way when we come into more complicated problems, in particular in Calc 2. So once again, our substitution is going to be u is equal to z squared minus 5. But we're looking at this integral more as, I'm going to rewrite it and kind of group it. So integral square root of z squared minus 5 end root. And then I'm going to put z dz back there. And this is what we want to find. We want to find a way to substitute directly in for that using this method. So same, whoops, I'm sorry about that. So same approach is once you make your substitution, you calculate the derivative, du with respect to z, du dz is equal to 2z. Okay, so now my goal is to algebra that expression that I have into z dz. So let's get the dz on both sides by multiplying by both sides by dz. Du equals 2z dz. And now since I just want this expression, what I'm going to do is I'm going to divide by 2 on both sides. And so what this tells me is that 1/2 du, or du over 2, either way you want to do it, is equal to z dz. And so we can directly substitute this quantity in for that. Okay, so let's bring our integral down here, equals circle star. So picking back up our integral down here, our integral under this substitution becomes the square root of u. And then z dz becomes 1/2 du. Once again, I can pop that 1/2 out front, and I'm left with the square root of u, or u to the 1/2, as we saw last time. And then we're actually at the point where we have the exact same problem. And that'll pretty much always happen with these methods. So I'm not going to rework the algebra here. I'm just going to state the answer once again. Same maths, 1/3 times the quantity z to the second power, minus 5 raised to the 3/2 plus c. Two ways, same answer both times. Should always work.